Hello and welcome to this video on direct proportion. We're going to be looking at answering a few different types of questions, such as find the rate, draw a graph, find the gradient, write the rule, and use the rule to determine values. So let's check it out. Okay, so first thing you need to know about direct proportion is that direct proportion graphs pass through the origin. So you already have a point straight away. They pass through 0, 0, all right? The graph of a direct proportion follows the rule y equals mx, okay? Soon you will see graphs that follow the rule y equals mx plus c, but we're not going to worry about that just yet. And we need to remember that the rate is the gradient, which is m. Rate means gradient. All right, I want you to lock that in your mind. And if you want to find the gradient, you're going to do the change in the y over the change in the x. Let's just get into it. All right, we need to decide which variable goes on each axis if we're dealing with real world situations. So one dead giveaway is that time, so seconds, minutes, or hours, is always on the x-axis. If you're confused which variable is which, time is always on the x-axis. And the variables on the y-axis are cost or distance or length, things like that. So you're looking at time will be on your x-axis or cost or distance on your y. So some examples of direct proportion relationships could be water is poured into an empty tank at a constant rate. So it starts at volume is 0 and volume is directly proportional to time. So that's an example of a direct proportion relationship. Water being poured into an empty tank. Or you got a car that starts at home and it travels at a constant speed. Distance is directly proportional to time. Passes through that point 0, 0. And we might have cost is directly proportional to the number of liters. So just remember, cost always goes on the y-axis. Sometimes volume can be on your x-axis, the number of liters. So just be careful there. So maybe you want to write these down and let's have a look. So our first question, a 200-liter fish tank takes 3 hours to fill. Determine the rate at which water is poured into the tank. So rate means gradient. Rate means gradient. And we have a letter for gradient, which is m. Now, if we come back here to 24, our gradient is the change in the y variable over the change in the x variable. So that means, let's look at this and think, which one will be our y variable and which will be our x variable? Will it be, let's have a look, a 200-liter fish tank. So we've got, takes 3 hours. Remember how I said time is always on the x-axis? So I'm going to call this my x variable. So time is our x-axis because that's time. So the other one must be our y unit. So change in y over change in x. And let's do it. We've got 200 liters, and put your units there, over 3 hours. All right, now I just chuck in my calculator, 200 divided by 3, 66.67. And let's say, and liters divided by hours. So we can rewrite that as liters per hour. You want to include your units of the rate. All right, we'll do a couple of these, so don't stress too much. Draw a graph of volume versus t using t is between 0 and 3. Let's go. Okay, volume versus time. So remember that time is always on your x-axis. So that's a dead giveaway. So we've got, and that needs to be there. So time, and then the other one therefore must be volume in liters. So include your units afterwards too. So time was in hours. And direct proportion graphs pass through 0, 0. All right, let's do it. So we know that that's a point on the line. I'm just going to do that in a different color. Pass through the point 0, 0. And we've also got another point. We've got T is 3. So it takes 3 hours to fill 200 liters. Say hours, I'll give it a bit of space. 1 hour, 2 hours, and 3 hours. So I'm going to look here. And so 3 hours on my x-axis, and that gets us to 200 liters. All right, 200 liters. So I'm going to say 50, 100, 150, 200. 200. And that's going to be a point. Another point. Let's do it in pink. And that's as simple as it is, really. There's your graph. Whoa. That's your direct proportion graph. Just the 0.00 and the 0.3, 200. Not too crazy. Okay, so we've done that. The T is between 0 and 3. Find the gradient. Well, we've actually done it up there. The gradient is the change in y over the change in x. So if we want to do it from the graph, m equals rise over run. And the rise is 200 units. Remember dropping a right angle triangle? There's another video on gradient. So the rise is 200 over the run, running along the ground. That's just horrible there. Hang on. The run along the ground is 3 units. And I always just include the units afterwards. So we've got liters per hour. And again, it was 66.67 liters per hour. Find the rule for V. Okay. Remember back here? The graph of direct proportion relationships follow y equals mx. So just write it straight down because it's direct proportion. And we want to leave our variables y and x in the equation. So I'm just going to replace m in there. 66.67x. Use your rule to find the volume after 1.5 hours. All right, and actually it says find the rule for V. So I'm going to replace, that's not good. It's going great so far. All right, I'm just going to write this here and replace with my real world variables. Remember I said that y was the volume, our volume, and x-axis is always time. So this is our rule. And now we're going to use that rule to find the volume after 1.5 hours. So V equals 66.67 T, which is 66.67 times, we are given T, so let's substitute it, 1.5. 66.67 times 1.5 gives me 100. 100.005, but let's just say 100 to 2 decimal places. And our units of volume were liters. And now it says, find the time needed to fill the tank to 100 liters. Okay, so I've got my rule. And this time we are finding time. So time is unknown and we're given the volume. Sometimes it helps to draw a little data table. So I'll say, okay, 100, substituting in volume. And this time we've got to do a little bit of rearranging to find T. So if we got 66.67 times T, we're going to divide both sides by 66.67. Because that's the opposite of timesing. That will cancel, and we got 100 divide 66.67, about 1.5 hours. And that should be confirmed by our graph. So let's look at time is 1.5 hours. That sits about here, well, definitely here, 1.5. And looking on our graph, does it match? Okay, the volume is 100 liters there. So you can always confirm it with the graph to get an estimate of your solution. All right, what's next? Okay, an electric bike travels 60 kilometers in 4 hours. Determine the rate of change of distance over time, i.e. the speed. The rate of change means gradient. Rate of change means gradient. And coming back here, we know that the gradient is the change in y over the change in x, y over x, which means we need to determine what's our y variable and what's our x variable here. All right, we've got distance and we've got time. And I know that time is always our x variable. Time is always on the x-axis. That means that distance should be our y variable. And I'm just going to substitute them in. So the gradient is y over x. So we've got some values. We've got 60 over 4. 60 over 4. Could probably do it in my head, but I didn't. 15. And I'm going to include the units. All right. So we had our y variable was kilometers. Our x variable was hours. So kilometers per hour. You can rewrite that fraction sign like that. Draw a graph of distance versus time using t as between 0 and 4. Oops. Distance versus... Oh. Sorry, that's great. Get out of here. Okay, so we know time's always on the x-axis. Time in our units of hours, and we've got distance. And that's in kilometers. And we know that direct proportion graphs always pass through the point 0, 0. We've got a dead giveaway there. Nice. And I'll just make sure that's all right. And we are also given some information in the question. At 4 hours, it's 60 kilometers. So let's go 1, 2, 3, 4 hours, it's 60 kilometers. 10, 20, 30, 40, 50, 60, nearly off the chart. And let's line it up. 4 is to 60, if you can see that. 4 is to 60. And then we just draw a graph. We've got 2 points. That's all we need to draw a graph. We're done. We've drawn the graph. Yay. Find the gradient. Well, we found the gradient up there, but let's look at the graph. Okay. M equals rise over run. Now, rise to get from the leftmost point to the rightmost point, we are rising 60 units. Rise equals 60. And we actually have to run across the ground, running 4 units. Okay. And so 60 over 4, 60 divide 4, I did it again, 15. That's the gradient, and let's include our units of kilometers per hour. Gradient equals rate. Find the rule for D. We know that graphs of direct proportion follow the rule y equals mx. So let's write it, just that basic rule, and then we're going to replace our variables in there, our real world variables. So our y variable was up the top here, distance. D, they're calling it D. And our x variable was, what's our x variable? Time, t. And we just need a value for that m, which was 15. We found the gradient m, and we have written our rule. Now it says use your rule to find the distance after 1.5 hours. So write your rule. What are we given? We're given t. So let's substitute it. 15 times 1.5. 15 times 1.5, and don't forget your units, 22.5. The distance is kilometers. Now they're saying the time to travel 40 kilometers. Oh, what am I doing? So write your rule first. 15t. Now what are we given? We're given distance this time. And we are trying to find time. So let's substitute in. D is 40. 15 times t. And unfortunately, we've got to rearrange. So if I want t on its own, that's being multiplied by 15. I need to divide by 15 on both sides. We're nearly done this lesson, all right? Just one more slide after this. And our time is 2.67. And what are our units? Our units are hours. And yeah, you could convert that to hours and minutes too, if you like, but I'm not going to cover that in this video for the interest of time. Now, and you can always double check this with your graph too. So at about 3 hours, what's the graph doing? So 2.67. So this is about 2.5 hours. So let's check this. We've got 1 hour, 2 hours. That was the run that I was saying was 4. So this is 1, 2, 3, 4. So at about 3 hours, sort of, we should expect a value around 40 kilometers. So 10, 20, 30, 40. Looking pretty spot on. So you can always confirm with your graph to back it up. Let's have a look real quick at this and let's finish by the 20-minute mark. Write a rule which links the following variables. Ben travels 500 kilometers in 10 hours. So these are all direct proportion relationships. Okay. Ben travels 500 kilometers. So I'm just going to say that this is a distance. I'm going to call that D, and this is a time. And we can write our direct proportion relationship straight away as y equals mx. And I just need to replace my real world variables. I know that time's always on the x-axis. So D equals something t. Now, remember, m is y over x when it comes to direct proportion. You just keep given a couple of bits of information. You just got to substitute it in. So our y was d over t, which is 500 over 10. So m is 50. Now this one, a plant grows 12 centimeters in 6 weeks. Okay, remember, what are your units? That's time here. And this is, let's call it height, h. Now I know that time is always on my x-axis. And so the other one must be h, y must be h. And we've got to replace m in the equation. M is y over x, which is h over t, which is 12 over 6, which is 2. So our equation, is going to be h equals 2t. And last question, the cost of fuel is $90 for 60 liters. Direct proportion, y equals mx. Now let's think of our variables. Now cost is usually on the y-axis. Cost is usually on the y-axis. Cost. So the other thing must be our volume, 60 liters. So I'm just going to say CV. C equals MV. And I need to replace M in that equation. Okay. So I know that m is the change in y over the change in x, which is our y variable. Where was it? I've lost it. Our y variable is c over v. So our 90 over 60. 9 over 6. 90 over 60. 1.5. M is 1.5. So let's replace it in the equation. And that's all that there really is to direct proportion. These are the key takeaways. You already have one of you're halfway there if you realize that direct proportion is a graph that passes through 0, 0. And then we also need to remember the graph follows the rule y equals mx, and we write equations leaving y and x in. So all you've got to do is find your gradient, and remember that the rate is your gradient. All right? The gradient is your change in y over your change in x. And remember these little bits. Time is always on your x-axis. Cost or distance is usually on your y-axis. But time is the dead giveaway there. So that's all I've got for you, and hopefully that helped, all right? I will see you soon.